Alrighty then, let's take a look at parabolas. So, by definition, a parabola is the locus of points or set of points that is equidistant from a point and a line. So, we should write that somewhere. The set of points that are equidistant from a point, and that point is called the focus or focal point, and a line, and that line is called the directrix. Alright, so, ooh, great, that's not good. Here, alright, later. Okay, so what this means is that, let's say we pick this point, okay, the distance from here to the focal point is the same as the distance from there to the directrix, and it's always the perpendicular distance to the directrix. The vertex of the parabola, notice how those kind of look the same, and then even if we pick something way out here, those two distances look the same based on my artistic license. So every point on the parabola, distance from here be the same as here, here to here, the same as here to here, etc. Okay, so some practical applications, in through focal point, out parallel. So one application is headlights, all right, in the front of a vehicle. So the way these work is the back is this parabolic reflector, and the light bulb is right here. So the light, any light that bounces off this reflector, you see how it goes out parallel. And this, I don't know what this lens part is here for, to direct the beam or whatever. But basically, you see how all these light rays are going out into a beam, and so that is so that the light comes out directionally and not pointing in all directions. For light or electromagnetic waves that are coming in, a satellite dish is a good example. So you see these outside the houses and condos here at Mammoth, where this is the receiver, and so from the satellites out in space, the wave, the signal will come in and bounce off and go here, or will come in and bounce off and go here, or will come in and bounce off and go here, or anywhere it bounces off, it all goes to this focal point, and so the receiver would actually be the focal point. So this little receiver receives that much signal. Okay. Oh yeah, this is going to be super messy. Great. Alright, so those are some practical applications. Hopefully your notes look better than mine. General info for a parabola is like this. So if it points up, let's write these. This is up, this is down, and this would be opening to the right, and this would be opening to the left. So notice how the equations are slightly different. Alright, so these are the general form of, if the parabola opens to the right or left, it'll look like this. If it opens downward or upward, the general form will be like this. And we're going to talk about that coefficient in front and how that affects the graph of the parabola. But that's some useful information right there. Alright, more specifically, we have this. So here's the vertex of the parabola, and the focal point, again, any point on the parabola, same distance from here to here, the directrix. That's how directrix is spelled. So the general form of the equation of a parabola is this. Y over 4p times x squared. And 1 over 4p, where p is the distance from, so let's zoom in here for a second. P is the distance from the vertex to the focus. That's the focus. And P is also the distance from the vertex to the directrix, which it would have to be because this is the same distance as this. Okay. And then the width of the parabola, which is called the focal diameter, I think this is written here somewhere, the focal diameter. So that is when you go from the focus, how wide out you go. And the total focal diameter here is going to be 4p, whatever p is from the equation. So notice how this can be written as, so this is the variable that is not squared, this is the variable that is squared. If we were to multiply by both sides by 4p, we could make it so that it looks like that. Okay, so we will practice, but this is all useful information and you have it right there. So would you go ahead and put this on pause. You're going to graph each of these. So use Desmos. Type in these equations. Desmos will show them in different colors. And you can graph those parabolas here. So go ahead and do that. Push pause and then come back and we will look at graphs. So hopefully you're back now, and y equals x squared would look like this. I'm just going to write the x part. Let's see, y equals 1/8 x. I suppose I could put a Desmos screenshot in here. That might even be cooler, but you're looking at Desmos right now. So 1/8 x squared would look like this. Negative x squared would be just like the red graph, only pointing downward. And the 3x squared, let's find some different color. Here we go. So this would be steeper. Alright, and so it asks us to describe. So I would say something like this is very steep or thin. For the blue graph, this is regular, so regular shaped parabola, but points downward or opens downward. And in red, we have the regular parabola that opens or points upward. And in orange, we have the 1/8 x squared. So this was basically a wide parabola. And it points upward as well. Okay, so just in general, what we're doing is we're looking at this coefficient, and that's going to tell us how the graph looks. For now, all of our parabolas will have vertices at the origin. Alright, so we're supposed to graph, find focus, directrix, focal diameter, sketch this graph. Okay, so we have an equation like this. Y equals 1/8 x squared. First of all, recognize that it is a y equals positive something x squared. So the parabola will point upward. And then we have to look at this number here. So this 1/8 is equal to 1 over 4p. So do you see how I set that up? And then I would cross multiply, and that would tell me that p equals 2. So we know a couple things. We know the parabola points upward. We know the vertex is at 0, 0. They all will be for, well, until we learn otherwise soon. And then p, so the distance from the vertex to the focal point, is 2. So our graph looks something like this, where we have our vertex right here, and then up to, this is our focal point. And notice how I went, so p, that distance is 2. And then I went 2p out and 2p out, and then I drew, and I know I did that beforehand, and then I drew the parabola. Voila! So here's our focal point, and this is at 0, 2. Our directrix is in the opposite direction of the focal point from the vertex, meaning down here, same distance, so p away, so 2 away, and it's not a point, it's a line. So here's our directrix, and if we were to describe the equation of that line, it would be y equals -2. That's a horizontal line. Alright, so there we go. Focal diameter, and that's 4. Whoops, I didn't say that. I said 8. The width of the parabola. Alright, focal diameter, 8. Up here, next. So, first, I divided both sides by 4. So this gave me this, x equals negative 1/4 y squared. So again, this number, this 1/4, is 1 over 4p. So if 1/4 is 1 over 4p, p is 1. Because this is of the form x equals negative y squared, it's going to be opening to the left. So we're going to have our vertex at 0, 0. Opening to the left, we go a distance of 1 to the focal point. So let's call that vertex. Let's call this focal point. And we know that the parabola is going to be doing something like that, but don't draw that yet. We're going to be more specific. We know that we go 2p, all right, so 2p this way, 2p that way, to come up with what the focal diameter or width of the parabola is. Alright, so we have a couple points, and then the directrix would be, so here's our vertex, here's our focal point. In the opposite direction we would have our directrix, and it would look like this. So directrix, and the equation of that line is, let's write directrix, come on there, stylus, directrix, and the equation of that line is, that's right, x equals 1. We need a bigger marker. That says x equals 1, and the coordinates of the focal point are negative 1, 0, and the coordinates of the vertex are 0, 0. Oh, and the focal diameter is 4, width of the parabola. Okay, so let's see. Similar, but now we're given a little, some different information. The vertex is at the origin, and the focus is at 0, negative 1/2. So, what's that going to look like? Here's our vertex, and focus is at 0, negative 1/2. All right, I'm going to zoom on in. And then let's see. Oh, this is going to, that point was too big. Okay, so here is our vertex, and our focal point is at 0, negative 1/2. So from this, it's obvious that p, the distance between the vertex and the focal point, is 1/2. So p is 1/2. We know that our directrix would be over here. So here's our directrix. And if you want to use multiple squares for this, that's fine. And then, so if p is 1/2, then we go 2p over this way and over that way. So our parabola looks like this. And the equation of our parabola, notice how it's pointing downward, so we know it's going to be something like y equals negative x squared, but we definitely need the number, the coefficient out here. And so we're going to get that by saying that 1 over 4p equals that number, where p is 1/2, so we plug that in. So 1 over 4p equals the coefficient. So let's see, 1 over 4 times 1/2. Half of 4 is 2, so there's a 1/2. So that is our coefficient in front of the x squared. I'm trying to get a different, alright, so for our final answer, we have y equals and a negative 1/2 x squared. Like so. Alright, so sounding good? Sounding good. What's this? Oh, here's our question. Got confused. Ha ha ha. Opens upward with a focus 5 units from the vertex, which is at the origin. So it's like playing Clue. So here's our vertex, and it's 5 units. 1, 2, 3, 4, 5. So up here is our focal point. This is going to get messy. That's okay. So we know that p is 5, and our focal diameter, we'd go p, and then another P, and P, and then another P. So 10 units each way. And it would look like that. There's our parabola. And we know that it opens upward. So the general form is going to be y equals positive x squared. We need to know that number, our coefficient out front. So we know that 1 over 4p is our coefficient, and 1 over 4 times 5. We're taking p and substituting it in here. So that leaves us with a 1/20th. Alright, so y equals positive 1/20th x squared. Looks good.